right, let's go. Our colleagues around the world, good morning, good afternoon, good evening. My name is Imad El-Durubi. I'm a principal architectural engineer practicing in the US and the MENA region. I also serve as the secretary of the International Code Council Global Membership Council, your host for today's webinar, Resiliency Considerations Beyond Code Requirements. I'm connecting with you from Cairo, Egypt, and I welcome you all on behalf of the Global Membership Council, Chairman Jeff Mitchell, the Executive Council, members, and the membership. The ICC Global Membership Council, one of the 6 ICC membership councils, founded on November 2011 under the guidance and the leadership of the ICC members. That is globally with the following goals: to establish the best method to gather input from global council members, to actively listen to interested global council members and explore a vision for our future, to give a voice to members of the governing committee and members of the council, to gain increasing active membership in the Global Membership Council, and most importantly, to connect building safety professionals from outside the United States with US-based professionals who have an interest in advancing the cause of building safety globally. Membership is open to anyone with an interest in the building safety, whether an International Code Council member or not. We are proud to building confidence, building community. Before I introduce our speaker for today's webinar, there will be 10 to 15 minutes at the end of the presentation for Q&A. For some reason, if we couldn't get to your questions, please, send us your concerns and we will be able to answer them. It's an honor and privilege to introduce Ms. Shamim Rashid-Sumar, Senior Vice President, Codes and Standards for the National Ready Mixed Concrete Association based in New York. She works with the National Model Building Codes and Standards organizations to advocate for resilience and sustainability through non-combustible construction and provides technical support regarding codes, standards, regulations, and legislations at the national, state, and local level. Engineer Rashid-Sumar holds a Bachelor of Science in Fire Protection Engineering from the University of Maryland, College Park. Shamim is a Fellow of the Society of Fire Protection Engineers and a member of the SFPE Foundation Board of Governors, as well as the SFPE Board of Directors, where she currently serves as President-elect. Engineer Shamim is a principal member of the several NFPA technical committees, including structures, construction, and materials, fire tests, and residential occupancies. She is also a member of the ACI 216 Committee on Fire Resistance and Fire Protection of Structures, ACI 560 Committee on Design and Construction with Insulating Concrete Forms, ASTM E05 Committee on Fire Standards, the ICC Performance Codes, and the ICC Multiple Hazard Resiliency for Residential Construction Committee. Engineer Shamim currently serves as, again, the president of the Alliance for Concrete Codes and Standards. Ms. Shamim, it's an honor. The audience are yours.
Thank you so much for that kind introduction, Imad, and I really want to thank everyone for joining today, and as well as the Global Membership Council for inviting me to speak. So I will just share my screen here. Bear with me one moment while I do that. I think this is the one. And just give you a minute to, hopefully that has popped up on your screen.
Yes, it has. Thank you.
Let's move some windows around. So as Imad mentioned, we'll be talking about resiliency today, and that's really considerations that are looking beyond code requirements. And so this is a presentation that we often provide for continuing education. And so there are some learning objectives here. We'll be looking at the increased risks from natural hazards and how resilient construction can support long-term sustainability by addressing life safety and building functionality. We'll look at approaches to mitigate the effects of natural hazards and focus a little bit on what resiliency is, what that means for a community in terms of their vitality and how they can work to towards safety through natural hazard mitigation. And we'll be talking about the importance of incorporating resilient standards in construction. And so the presentation goes through a few different parts. I'll be examining the impact of fire and other natural disasters. We'll take a deep dive into what resilience means, a look at steps to getting to disaster resilience, and also how we quantify the benefits of incorporating resilient construction. And then hopefully I'll have time to go through a few case studies before concluding and taking some of your questions. And so when I talk about the impact of natural disasters, we're going to look heavily at the costs of natural disasters and then compare that to what the cost would be later on in the presentation to build for resilience. And so for a lot of the data that I have is US based, but it gives you a picture of what the impact of natural disasters, what that impact looks like. And so for millions of people in the United States, in particular, the consequences of natural disasters have become real, personal, in addition to just devastating. So in 2024, this is data I have from the National Oceanic and Atmospheric Administration. In 2024, in the United States, there were 27 separate weather and climate disaster events that had losses exceeding $1 billion, and that's across the country. And these events in 2024, they included a severe drought event, one flooding event, 17 separate severe storm events, 5 tropical cyclone events, 1 large wildfire event in 2024, and 2 winter storm events. So these events resulted in the deaths of over 500 people and had significant economic impacts on the areas that they affected. And so 2024 was actually the 10th year in a row where there were 10 or more billion-dollar weather or climate disaster events impacting the United States. And this, there have been several years with 10 or more separate billion-dollar disaster events, including as far back as 1998, 2008, 2011 to 2012, as well as this 10-year period from 2015 to 2024. And so, however, across that last 10 years, 2017 was the costliest year on record for natural disasters in the United States, with a price tag of $306 billion. And so if you recall, in 2017, that was the year that Hurricane Harvey broke a rainfall record for a single tropical storm with more than 4 feet of rain in Southeast Texas, and it matched Hurricane Katrina as the costliest tropical cyclone on record. And that 2017 was also the year, if you remember, Puerto Rico was mired in recovery after Hurricane Maria, and about 3,000 people were estimated to have died in that storm and its aftermath. So we're going to talk a little bit about these different types of disasters and how each of those impact in the bigger picture. So when we talk about wildfire, I have some statistics here on the cost of wildfires in the United States. According to various internet insurance solutions, just under 5 million US homes are at high or extreme risk of wildfire, and about 2 million, so nearly half of those, are in California alone. There have been over $23 billion worth of loss to wildfire in the US over the past 5 years from 2024 backwards. And again, 2017 was that terrible year. There were about $17 billion worth of loss due to wildfire. And it's estimated that that loss will continue to grow as we continue to experience different climate patterns, which create warmer and drier conditions year on year. And so we continue to build in fire-prone areas. And as we continue to do that, the damages that will be caused by wildfire in those fire-prone areas will continue to increase. And it's interesting that we continue to build back after wildfires. Sometimes, instead of building back to higher standards, we see that policymakers will issue permits to rebuild without updating to the most latest building codes, and sometimes exempting residents from zoning rules so that they can build larger homes and build back more quickly. And so sometimes state officials have even mandated that insurance companies not raise insurance rates for people in fire-prone areas. So that means that it just passes the cost on to homeowners elsewhere outside of those fire-prone areas. And we've seen more recently an even bigger problem in that insurers will refuse to insure homes in hazard areas at all, and that's becoming true as well. And so when we look at wildfire risk in the United States, we notice that it's not just a problem that's limited to California or that's even limited to the West Coast. You see this map from Forest and Rangelands, which shows wildfire risk across the country. And you'll notice the deep dark orange is high fire risk. That is covering more than 50% of the country. It's covering the western half of the United States and almost the southern half of the United States. And you'll see a lighter orange and a lighter yellow creep up in other areas where you wouldn't consider to be fire risk, including areas along the eastern seaboard. And this is not a problem. I'm mentioning US statistics because that's what I have easiest access to, but wildfire is not a problem limited to the United States. It's really an international problem. So you have wildfire activity causing devastation in areas such as India, even in areas of the Middle East, such as Lebanon. And then if you remember back to 2019, 2020, the Australian bushfire season of 2019 had hundreds of uncontrolled fires, which peaked in December, January. And it was estimated that 46 million acres were burned and almost 6,000 buildings destroyed, including almost 3,000 homes. And sadly, over 30 deaths resulted from that wildfire season in Australia. But if we switch now, not to just wildfire, but structure fires, according to NFPA, there were almost 500,000 structure fires in again, that 2017 year, causing just under 3,000 deaths, over 12,000 civilian injuries, and $23 billion in damage. So structure fires are a major problem. Property damages from fires have been increasing over time. And structure fires, whether they're caused by accident, arson, or wildfire, they result in significant loss of life and property each year. And fire kills more Americans than all natural disasters combined. So that's a very harsh statistic. And, you know, as developers increase the use of combustible construction, this really impacts multifamily construction, including apartments, condominiums, hotels, dormitories, even long-term care facilities. There are a number of fires that continue, structure fires, and these buildings are often, or groups of buildings are often, total losses, putting lives and communities at risk. So I have some more statistics to kind of close off that picture of the impact of natural disasters. This is a graph adapted from, again, the National Oceanic and Atmospheric Association, and it just shows that the number of billion-dollar disaster events are increasing year on year, and also the cost of those events. So there are more events and they're becoming more costly. You can see this graph shows that upward trend, and you can see the dashed trend line. There are kind of ebbs and flows. Again, remember that 2017, that sharp peak you see, that's the most costly year on record. But you can see even in 2024, there's that upward trend line across the last 40 years. So why are disasters costing more? According to the US Census Bureau, over the last several decades, the population in the United States, and we would assume that this is following trends globally, the population has increased and then migrated towards the coasts. So concentrating along earthquake and wildfire prone Pacific coast, and also along the hurricane prone Atlantic and Gulf coasts to the south. So we've talked about, what the impact of natural disasters are, how deadly they are, how costly they are. We're going to transition now to a little bit more positive, looking at what resilience is, defining resilience, and taking some resilience-based approaches to hopefully mitigate those losses. So there are several definitions of resilience. If you looked in the dictionary definition would be the capacity to recover quickly from difficulties and toughness. I particularly like the definition from the Urban Land Institute. This is defining resilience as the ability to prepare and plan for, absorb, recover from, and more successfully adapt to adverse events. So looking to address changes in the environment, whether those changes are natural or man-made, and looking at actions to mitigate the negative effects and adapt to those changes. And there's, different components of resilience impacting social well-being, environmental sustainability, as well as economic development. So I like to look at this sort of chart to look at what resilience means. And so if you look at the x-axis, we're looking at time to recovery. And if you're looking at the y-axis, we're looking at functionality in a building. And so if you look along the x-axis, you have in time, you have this orange curve, which is, baseline design. And then you see this dashed line right here in time, which occurs, which is some disaster event. And there is sort of this downtime where repairs are being completed to get the building back online before you're at, again, baseline functionality. And that sort of dip in the x-axis is lost functionality, right? Now, if you look at this yellow curve, this is representing a building that has taken some approaches to plan for and mitigate towards disaster events. So it has, it's reaching this dashed line in a little bit of a better situation, and that dip is not so severe. You can see the time to functionality is much less than that other building that did not take any action. And so that lost functionality, first of all, the severity of that lost functionality is less, and then the time to recovery is much less as well. So this is a good way that I show, a nice way to show what taking resilience into account, how that is impacting functionality and time to recover. And if we think about sustainability without thinking about resiliency, we're considering environmental impacts, but we're not considering the impacts necessarily of a disaster event. So that is something to keep in mind as we talk about. This is another sort of Venn diagram, which is adapted from the work of Dr. Brian Meacham and Dr. Margaret McNamee. And this was a study that they did on the fire safety challenges of green buildings and attributes. And this was done in coordination with the Fire Protection Research Foundation. So this is a Venn diagram showing what you would consider in resilient construction, what you would consider in sustainable construction, and what you should consider to think about both of those aspects. And so if we're thinking about sustainability, we're looking at reductions in energy and material use. We're looking at increasing our reliance on alternate energy, energy storage, recycled materials, and having an overall better air quality. And on the resilience side, we're looking at reducing exposures to hazard, reducing the multitude of failure modes, or reducing the probability of failure modes. We're looking to increase robustness, redundancy, reliability, and better adaptability to change. And so if we're looking at disaster events, really the target is to achieve both the sustainability and resiliency targets for this case. And then one final way to look at resilience-based design, many of us are used to the concepts or used to practicing in prescriptive or code-based design. And, over the years, there's been sort of an evolution to performance-based design. And in time, hopefully, we are evolving to resilience-based design. So code-based prescriptive design really considers the design and construction phase of a building life only, is focusing primarily on life safety and keeping in mind actions or design choices that might be capital intensive. It's very prescriptive, so it's based on code requirements. And usually code-based design is looking at an individual building in terms of the design and construction phases. If we look at performance-based design, again, still mainly focused on the building design and construction and not the life cycle of the building. But in addition to safety, it's looking at potentially damage and recovery as part of the performance requirements. It's not just looking at the capital that's required, but also looking at what the occasional impacts of insurance occasionally performance-based design will look at insurance impacts and consider the insurance industry as a stakeholder. There will be some advanced analysis may be done in addition to what the prescriptive provisions might be, and still focused on individual buildings. But as we look at resilience-based design, it's looking at the complete life cycle of the building. So not just design and construction, but the use of the building all the way to the retirement of that building. It is looking at safety, damage, and recovery. And it's looking at not just the intensive capital during the design and construction phase, but it's looking at the capital needed to maintain operation of the building and also build reserves over the life cycle of the building. It's going to look at external issues, not just during design and construction, but externalities, again, such as what possibly weather events might occur, what political events may impact the building. And then also looking at the relationship to the community that the building or portfolio of buildings is in, or the organization that the portfolio of buildings is in, not just a single building. And as part of resilience-based design, there will be a need to consider a comprehensive resilience framework. So this is just one last way to look at how resilience-based design compares to traditional design. So now we'll get to the meat of the presentation, and that is to what are the steps we can consider to disaster resilience? How can we incorporate disaster resilience into our design and planning process? And so there are a number of steps that are there. Two sort of camps, voluntary programs where communities or building owners voluntarily reduce their risk of natural disaster through enhancements in structures, warning systems, and education. And then there's the mandatory approach to include building requirements such that communities and building owners are obligated to design their buildings and infrastructure to be more disaster resilient. And so we're going to look at 4 different steps today. On the mandatory side, looking at adopting updated building codes as a first step, looking at adopting high performance building standards. And then on the voluntary side, looking at ways to incentivize disaster resilient construction and then also voluntarily build with more robust materials. And so as a first step, adopting updated building codes is always the first step in disaster resilience. And there's a common misconception that, if you build to the building code that's adopted in your jurisdiction, you are building resilient. But again, building codes minimum provisions are really looking at life safety. So your ability to get out of a building quickly, it does not necessarily mean you're designing your building to withstand an event long term, or for functionality, for resilience. Those are not part of the scope of minimum building codes. However, if you are building to building codes, you're a lot better than not building to building codes. And if you're building to updated building codes, you're better off than building to building codes that might date back to 2015 or 2017, or which we do have in some jurisdictions in the United States, and perhaps globally as well, as jurisdictions struggle to go through the process of adopting updated building codes. But that really is the first defense, and encouraging your jurisdiction to have a regular adoption cycle is the first step to achieving resilience. And then the next level would be looking to adopt high performance building standards that go above, maybe beyond minimum code requirements. And there are a number of programs and standards that are aimed at incorporating resilient building techniques into construction on top of what building codes require, to provide a more optimum level of protection against a number of natural hazards. And so we'll look at a few of these. Again, we'll look at enhanced building codes and standards, and we'll go through what some of these other programs are. The Fortified program, building rating systems such as the U.S. Resiliency Council, and READY and RELY as well. So when we're talking about high performance building standards, enhanced building codes can be developed and adopted through, for instance, building code appendices. So there are appendices, as an example, provided to the International Building Code and the International Residential Code already, to offer supplemental criteria to provisions in the main chapters of the code. And I have an example here of a jurisdiction that actually offered what they call Appendix N, which is a disaster resilient construction appendix. This was adopted in the state of Georgia as an addition to Georgia adopts and amends the International Building Code. So they actually adopted this Appendix N after damaging windstorms that they experienced in 2008. So that is when the Georgia Department of Community Affairs created this Appendix N to the IBC, as well as their adopted International Residential Code. And so both of those codes form the Georgia State Building Code. And this Appendix N, it attempts to offer an affordable, flexible, and simplified approach to improving resiliency at the local level. So local jurisdictions can choose to adopt the complete appendices to improve their building resiliency against flooding or high winds, or both, depending on what they experience in their jurisdiction. Or they can just adopt certain sections that apply to specific hazards in their geographic area. But this appendix allows them to mandate some provisions above what minimum code requirements would be. And then I have some other examples of high performance building standards that can be adopted. These you can see on the left, ICC 600. That's the ICC standard for residential construction in high wind regions, and that is published, available as of 2020. And the ICC Multi-Hazard Resiliency for Residential Construction Committee is actually working on a suite of standards for resiliency for residential construction, aimed mostly at 1 or 2 family dwellings. You can see in the middle here, the ICC 605 standard, which is a standard for residential construction in regions with wildfire hazard. A public draft is already out. You can find that on the internet, and it's going through the ANSI process through the public comment period, and it will be published soon as a wildfire resilience standard. And in the future, there will also be, as part of that suite of resiliency standards, there will be an ICC 610, which is the standard for resilient residential construction in regions with seismic hazard. And then also in the future, 615, which will be a resilient standard for residential construction in regions with tsunami hazard. So you can actually go to the MHRRC committee page, which I've included the website here below, to get more information and keep up with that development process of those standards. There are other high performance building standards that are available. One of them was developed by the Insurance Institute for Business and Home Safety. This is the Fortified for Safer Living and Safer Business. And these programs, they provide enhanced design criteria above code minimum provisions. And they also include construction and inspection oversight to make sure that what was designed is actually installed and constructed in the buildings. IBHS is a not-for-profit research and communications organization that works closely with the insurance industry. So there are several states that recognize Fortified and mandate that insurance companies provide lower premiums if you adhere to the Fortified program. And I'll go over that a little bit later when I talk about incentivized programs. And the U.S. Resiliency Council, which this is another high performance building standard through their USRC building rating system. So the USRC is a organization that is looking to improve sustainability and resiliency of buildings during earthquakes and other natural hazards. So they have a rating system based on 1 to 5 stars, looking at the dimensions of safety, damage, again, expressed as repair costs, and then recovery expressed as time to regain basic functions. So that graph that I mentioned earlier. So that rating system, certified buildings would be expected to perform in a manner that will not only preserve life safety of occupants, but also limit damage to repairable levels and allow functional recovery within reasonable time periods after a major seismic event. So right now, the USRC has a rating system for earthquakes as well as wind. They've recently come out with a wind rating system, and they'll be working on other rating systems for other hazards in the future. And then there are 2 other rating systems, the READY, which is the Resilience Earthquake Design Initiative rating system, that is looking to minimize building damage again and promote contingency planning for utility disruption and other threats to functional recovery, and the success of the resulting design in meeting specific monetary loss and recovery time is demonstrated for this rating system by performing a modified P58 loss assessment, which was developed specifically for the READY rating system. And then the RELY standard is another point-based system developed by the U.S. Green Building Council. So it includes many credits for building to the LEED standard, as well as credits for taking risk mitigation choices at the building and neighborhood scale. So it's intended to provide adaptability and resilience to weather and other natural hazards, in addition to complementing the LEED, which is sustainable design standards. Next, so those were sort of some involuntary ways to capture resilience or design for resilience. We're going to look now at voluntary methods, which, if you remember, the first one was incentivizing disaster resilient construction. So I have some insurance statistics here. According to Munich Re, which is insurance company, insurance companies took $135 billion hit. I remember that 2017, that drastic, year in the United States, but it was also a drastic year globally. Insurance companies took $135 billion hit from natural disasters that occurred globally in 2017. And we mentioned many of those losses were in the United States. So when we're looking to incentivize disaster resilient construction, one way is to provide insurance incentives. And I mentioned the Fortified program. The Fortified program is a regulatory framework for insurance incentives. And this is a way that states can encourage building owners to build resilient by legislating insurance premium reductions to policyholders if they build to the specific resilient design criteria as specified in the Fortified program. So there are a number of states that have gone ahead and adopted this legislation. A few examples: Alabama, Georgia, Mississippi, North Carolina, and Oklahoma. They all have enacted such laws, and these states require insurers to lower the cost of property insurance if those buildings are built to the IBHS Fortified standard. And there are other ways to incentivize disaster resilient construction. This can be done through loan security by lending institutions. So this would decrease business interruption, improve bond ratings for property owners and communities. Different incentives such as building permit rebates, property tax reductions. If you are building resilient, having a pathway to accelerated permits, providing zoning benefits, so maybe higher density or height bonuses to buildings that have built or incorporated resilient provisions, having more favorable agreements with developers based on construction of resilient properties, and having favorable revolving loan programs, particularly for buildings that are built to more resilient standards. And finally, the last step towards disaster resilience is just to build better, build with more robust building materials. So some of the qualities of more robust materials include increased strength, resistance to water, so resilience in terms of a flood event or storm surge, seismic resistance, so being able to withstand earthquakes, fire resistance, having more energy efficiency, and being more durability in terms of length that the building will be able to stand. So again, fire is one of the most frequently occurring disaster and the most costliest and deadliest. And the U.S. Fire Administration again reports that every year fire kills more Americans than all other natural disasters combined. So I'm going to talk a little bit about what building with robust materials look like. Obviously, I represent the concrete world. So concrete building systems are a good example of a material that is especially suited to provide resistance to natural hazards. It can withstand extreme weather. It has that hardness and stiffness in its mass to resist high winds, flying debris from tornadoes and hurricanes. Concrete is also non-combustible. It will contain fire and will not contribute to the spread of fire. And reinforced concrete framing systems are an example of a way to design to resist not only fire, but the most severe earthquakes without collapse. And one other tidbit: concrete does not does not rust, even if it is subject to flooding. It does not corrode. Typically, if it has any metallic materials for reinforcement, it may, but any concrete that's reinforced with non-metallic materials often resists corrosion. And also concrete does not mold as well. And so on the right-hand side here, I have a picture of a tilt-up concrete wall system. And then one other concrete system that I usually like to highlight because of its many benefits. Some people are not aware of this concrete system, so I like to highlight it for that reason as well. And that is insulating concrete forms. So this is a unique concrete system because the forms that are used actually stay in place. They are comprised of EPS, which is expanded polystyrene foam insulation on both sides. So that foam comes as sort of a block assembly held together by these plastic ties. The blocks are put in place and then used to build a wall, and then the concrete is poured in between. And what this does, it builds in insulation to the wall. So these forms will stay in place and provide continuous insulation. And then the way these ties work, they serve as furring strips, and they can be used to attach different finishes. So I often get asked about the EPS foam. This foam is special. It is fire retardant, treated with fire retardants. This system itself has to pass a number of fire tests for surface flame spread, surface ignition, lateral and horizontal flame spread. So it is a heavily regulated construction method. And this also is tested as an assembly to ASTM E119. So it does also carry a fire resistance rating of anywhere from 2 to 4, or I've even seen higher fire ratings for this construction method. So those are some examples of different robust systems and robust materials. We're going to move now to quantifying the benefits of resilient construction. There's often an argument that building more resilient using these robust materials is more expensive than building with traditional materials, more either combustible or less stiff materials. We're going to look at quantifying what the benefits are to provide that cost benefit to taking resilient measures. So there are a number of studies that are out there that look to quantify the benefit of resilient construction. I've picked out 5 that we'll talk about here today. There's the Urban Land Institute's Return on Resilience Business Case Study. NRMCA, my organization, did an insurance cost study. There are studies done by the National Institute of Building Sciences. There's the U.S. Resiliency Council Seismic Performance Study. And then there are other tools that are used, such as the MIT, Massachusetts Institute of Technology's break-even mitigation percentage tool. So I'll touch on all of these very briefly. The Urban Land Institute has a report called Returns on Resilience, the Business Case, and it explores the economic benefits of resilient construction. So this study is based primarily on interviews with developers, property owners, and their consultants to identify the motivations that they had to protect their assets against climate-related threats, such as what resilience strategies were selected, what the design and development processes looked like for them, and ultimately how their projects perform. And in all cases, the projects were able to demonstrate economic justification for spending more upfront to design and build resilient structures. So the hazards that were addressed in those designs included inland flooding, drought, hurricane wind, and storm surge. And then NRMCA, as I mentioned, undertook a research study to determine if insurance companies were offering lower insurance rates or premiums for structures that were built using non-combustible materials versus combustible materials for both builder's risk insurance and commercial property insurance. And one of the main drivers behind this study, again, was the enormous loss that in buildings each year due to structure fires. And so the study was titled Survey of Insurance Costs for Multifamily Buildings. It was looking at 5 different cities, Los Angeles, Dallas, Edgewater, New Jersey, Towson, Maryland, and Orlando, Florida. And these were cities that actually corresponded to areas that had had very large structure fires, conflagrations in a multifamily development. And the study actually surveyed insurance agents to see, what if they were offering or if there were differences in the premiums. And you can see here that the insurance premiums were higher for both builder's risk and property risk. And you can see the percentages here. They were higher for wood frame construction versus concrete construction. And according to the study, some agents suggested that the gaps for those rates between wood frame and concrete would actually grow in the future, and that some insurers may even decline to serve as the sole insurer in the future for wood frame apartment buildings. And so we wanted to see if that would be the case. If this study was done in 2017, we actually did a refresh of that study in 2023 to see if that difference in costs was growing. And so we partnered with the Concrete Advancement Foundation to recommission this insurance study in 2022 and 2023. And so this study again solicited quotes for a reference building. So this was the reference building used in both studies. It looked at a 100,000 square foot 4-story apartment building in the same five reference cities, and it asked for quotes for a wood frame apartment building and a quote for a concrete building. And in that study, you can see those differences, the gap between what those premiums were for combustible and non-combustible construction did grow. Once again, the insurance companies consistently confirmed that the cost of building insurance for a typical apartment building is lower when that building is constructed with concrete versus wood frame. And this applies to both builder's risk insurance and commercial property insurance. So that difference was as high as 80% less, you can see, in an area such as Los Angeles, which is subject to seismic events. And then that smallest difference, if you look at places like Dallas, Texas, it's a little bit less. Orlando, Florida, on the property side was a little bit less. And some other interesting pieces of information. In this survey, we found that there were some insurers that were refusing to even insure wood frame buildings at all. This was the case in Florida, for instance, which we did not find in the previous round of the study. There are a couple of other studies that I want to share with you. This one from the National Institute of Building Sciences. It's called Mitigation Saves, and this report was updated in 2019. This study looked at quantifying the value of designing buildings to exceed, at the time, the 2015 IBC or IRC for hazards. So if you designed for hazards including riverine flooding, hurricane surge, wind, earthquakes, and wildfires, what would be the value for designing buildings to exceed minimum building code? And the results revealed that for every dollar that you spent on building above code, the amount of money saved ranged from $4 to $7 for each dollar that you spent, depending on the hazard. And so if you look at this for a riverine flood, if you spent $1, you would save about $5. For every dollar you spent for hurricane, you would save $7 from hurricane damage, and so on and so forth. So the overall benefit to cost ratio, for every dollar you spend towards resilience, you are going to save $4 for every dollar. And some of the strategies that were looked at to exceed minimum requirements for the 2015 building codes included building new buildings higher above base flood elevation, higher than the elevation that was required by the 2015 IBC for flood resistance. For resistance to hurricane wind, it was looking at homes that were built to comply with IBHS fortified home hurricane standards. For resistance to earthquakes, it was looking at buildings stronger and stiffer than required for the IBC 2015 IBC. And then for fire resistance, buildings to comply with the 2015 IWIC, which is the International Wildland Urban Interface Code. Some other, the report also suggested that architects and engineers can help clients understand the potential risks that are associated with a project and determine what an owner's risk tolerance and ability to mitigate those risks might be. And then it also suggested that major stakeholders, including developers, lenders, tenants, communities, can all benefit from resilient construction. And the greatest benefit is to building owners who don't have to spend as much to repair and rebuild after a disaster. And also tenants can benefit from having functioning shelter, not having to be relocated after a disaster. And I think I included, yeah, here you can actually download that program, report in full and read the mitigation saves report. And then just two more studies that I want to share. One is the USRC seismic performance study. So this was actually commissioned by the NRMCA. And we asked the USRC to compare seismic performance of multifamily residential structures based on 4 different construction types. The first was traditional wood framing. The second was cross-laminated timber or CLT, steel framing, and then concrete, a concrete building built using insulated concrete forms. So this looked at that same multifamily building that was used as the reference building in the insurance study, but it looked at 3 different areas. It looked at Los Angeles, which has high seismicity, also Seattle, and Memphis that have varying levels of seismic activity. So the results of the study demonstrated that more resilient configurations, such as the concrete construction, produced significantly higher lateral force strength and 4 to 5 times higher building stiffness than the other configurations. And the study showed that property losses in a design level event were approximately 170 to 270% higher for the wood, CLT, and steel configurations as compared to the concrete configuration in Los Angeles and Seattle, and a little bit higher, not quite as high, 40 to 85% higher in Memphis. And you can see that in the graph on this slide. And then finally, there's this MIT has a break-even mitigation percentage tool, which you can look up online. And that's looking at the full life cycle of the building, not just building, but also looking at energy use, wear and tear, hazard repair, and then what the end of life looks like, including waste recycling, labor, equipment, and energy to demolish a building. And so this break-even mitigation percentage tool evaluates the cost effectiveness of mitigation for a building in a location by factoring in expected damage that a conventional building designed to code would endure over its lifetime. And then it compares that to the cost of a more resilient enhanced building designed to justify a building to a higher standard. So you can see this comparison, what the value would be over the present value of life cycle cost. It would be $800,000 for a conventional building versus the life cycle cost for an enhanced building built to resilient standards. You can see that's in the $500,000 range. So this is an example for a 2-story wood frame single family home in New Orleans, and looking again at what hazard repair, improvements, maintenance, energy, and initial cost would be. Okay, so hopefully that gave you an idea of some of the approaches to building resilient, the standards to building resilient, different building standards, and again, what the cost benefit analysis, what that cost argument is to build resilient. I do have a few case studies, which I'll try to go through quickly. Or Imad, should we break for questions? You're on mute, so I can't hear you. I'm sorry, I still can't hear you. You're muted.
Okay, Shamim, please go ahead and continue with the case studies, and we'll have a few minutes for Q&A. Thank you.
Okay, perfect. So I've picked out a few case studies to kind of show what resilient construction looks like in practice. The first one is a case study in Miami, and this is the Brickell building. And when it was being designed, Miami was recovering from the impacts of Hurricane Wilma. And so many high-rise buildings in Miami suffered extensive damage and were out of commission for extended periods in this area. So the developer wanted to, was willing to increase construction costs if he could build to withstand those types of events in the future. And so he was willing to increase construction costs to realize that long-term operability. So this is a 35-story, almost 600,000 square foot office tower. It was designed to withstand the force of large projectiles, and it could also withstand speeds approaching 300 miles per hour, as well as storm surge. So integrating resilience was a big deal. It involved a reinforced concrete structural system using post-tension one-way slabs and beams. This was elevated portions of the ground floor above the floodplain. It used impact-resistant glazing systems, and then also multiple backup generators to maintain business and continuity for tenants. So it costs an extra 6 to 8% to implement these resiliency strategies, and that was actually immediately recouped with more competitive insurance rates and lower operating expenses. So that was about $1 million worth of savings just in electricity alone. So that extra 6 to 8% paid itself back almost immediately. And then many global companies that were concerned about business continuity across time zones, high-profile tenants were interested in leasing this space in the Brickell faster than other nearby Class A office space. And this building was also awarded LEED Gold certification. And then the next case study I have is regarding a site in Milwaukee. This is Walker's Landing. And so this is a pretty typical building, two buildings, residential buildings, 6 stories each, 4 floors of residential over 2 floors of parking. But the site had restrictions. So there was a 10-foot setback from a river. There was a bridge on one side and 2 streets on the other. So it had setback requirements for fire resistance rating. And then it also had, challenges with access for material storage and construction activities. So this was built using concrete walls, insulated concrete form walls to get that fire resistance, among other benefits. Because this was on an infill urban site, again, requiring that fire rated exterior walls, they chose to go with the concrete. It was cost savings over fire retardant treated wood. And the developer also chose ICF walls and precast hollow core floors for that thermal efficiency I mentioned. This is in Wisconsin, a very cold climate, and also for speed of construction. So this was one other case study. My favorite one, it's not a great story. It's a little bit sad, but my favorite case study, because this is in Harlem, East Harlem, New York. This was a concrete apartment building that survived a blast. So this happened in 2014. There was a natural gas explosion. So it happened right, hopefully you can see my cursor. This is the concrete building. It happened right next door to that building. This building here, there was a massive natural gas explosion. it did actually destroyed this building and another building beside it. And 4 neighboring properties had to be vacated because of the debris. It shattered windows, even blocks away. Some of that debris landed on the elevated, in this area of New York City, the subway is actually elevated above grade. And that debris landed on the subway tracks. So that shut down travel to and from Manhattan for the day. This explosion was big. It resulted in 8 deaths, 70 injuries, again, 100 displaced families, massive emergency response. Over 250 firefighters, paramedics, and police officers responded. This made history. It was in the news. The local utility, Con Edison, was found responsible for that gas explosion and responsible for over $150 million worth of damages. But the good news story here is this ICF building, it actually survived that explosion. The New York Department of Buildings report, acknowledged that this was remarkable considering that it was inches from the explosion. And the other buildings were not so lucky. And so I have some more pictures here. So this is on the day, or very close to the day of the explosion in the middle. The picture on the left is before. So this is the actual ICF building here in the middle of the first picture, and this building next door is the one that exploded. And you can see in 2015, the building is after minor repairs, again, because of debris pierced the roof of that ICF building. During the firefighter response, some water damage occurred. So there were some minor repairs, but this building actually reopened very quickly. And the reason that this building survived is because ICF is actually blast resistant. And we know this from some tests that were done, force protection tests that were done in 2003 that demonstrated the blast resistant properties of insulated concrete forms. And this testing involved these reaction boxes that you see in this middle picture. So this testing was done. The acceptance criteria is that military personnel inside the structure should survive the blast. And so these reaction blocks don't have any exterior cladding. They're just ICF boxes. They were subjected to blasts from a 50-pound charge of military grade TNT at distances ranging from 6 feet to 40 feet. And so based on these tests, there was limited damage observed to the structure. And so they passed the tests. And what's happening here is that insulation, that expanded polystyrene, is absorbing energy from the shock waves and dissipating the energy over time, and therefore cushioning the concrete so that it is not impacted by the explosion. And then the final case study that I have is from a wildfire where non-combustible exterior finishes saved a home from devastating wildfire. This was in Laguna Beach in 2013. So this was a wildfire that was pushed by the Santa Ana winds in Laguna Beach. It consumed 17,000 acres, destroyed almost 400 homes, and damaged 500 more in a single day. And the fire was being fought, there was a huge demand on the water district's, the district's water system. Reservoirs were being drained faster than they could be filled, and 6 of the district's 22 reservoirs were actually completely drained during the fire. So this was a huge wildfire event, consuming approximately 16 million gallons of water over normal usage needed during that period for battling those fires. But in this devastation, you can see this one house here survived. It was protected by an envelope of non-combustible materials. It was spared due to not only the construction, but the landscape design. The detailing included stucco cladding on the walls, Class A concrete tile roof that was sealed on the ends to hide any exposed wood under the eaves, and this prevented combustion of this home. It also featured double pane glass, which helped keep heat from igniting draperies inside the house. There were landscape zones of plants that were more resistant to fire than normal vegetation. And the property also had no tall flammable trees near the house. So this was, it had a defensible space that spared the home. So this is the final case study that I have. Certainly open to any questions.
Shamim, before we get to the question, I just wanted to say, what a remarkable presentation. And thank you for sharing so many points that is so important globally. So I appreciate your time on behalf of the Global Membership Council and the ICC. Thank you so much for this wonderful presentation. And with that, please, if there are any questions, Shamim will be happy to take them. Lawrence, are you there?
Yes, I am. You're welcome to also just let us know if you have a question in the chat window. Otherwise, we have a small group with us today, so I'm sure Shamim can answer questions. If you want to unmute yourself and ask your question, please feel free to do so.
Okay.
From my perspective in the UK, it's trying to put together the size of some of these events compared to the actual area in the UK. Some of the things you deal with are quite enormous. And I felt the slides and the spoken word was very, very good, very positive. And I enjoyed the presentation.
Thank you for that comment. One of the challenges I have is, here a lot of this data is freely available and it's easy to compile and share. I'm challenged to know where those resources are sometimes overseas. I'm curious if this similar data is available in the UK or other countries.
David, do you have any comments on that?
And I know sometimes you can't think of a question right away, but I've listed my email here and you're certainly welcome.
Shamim, I have a comment, if I may. As you travel outside the United States, could you just touch on other experiences that we have, perhaps in the MENA region or other areas?
Yeah, for sure. And I worked in the MENA region from about 2007 to 2019. And so I would say the landscape of codes and standards, from the beginning to the end, there was tremendous growth. But when I first got there, I was I don't know what the exact word is, but there wasn't a building code that was adopted as standard. When there was a design or a team working on a building, they would pick their own code and they would design to it, which got to a little inconsistency of provisions between buildings. So when you're thinking about resiliency of a community, you have one building that's designed according to some codes and another one that's to different codes. And these could be like the Chinese code because the design team and the investor was Chinese. It could be the GCC code because that's what typically was designed. So it makes for an interesting dynamic when you're thinking about density of buildings in an urban area and the risk that's posed, maybe not by your building, but from the adjacent building. So, one of the challenges that we faced in the Middle East was, and this was also experienced, in the UK, was with combustible cladding. And so maybe your building had cladding that was okay, but a nearby one had combustible cladding, had a fire event, and now impacted your building. And so there were different dynamics there that came into play because of differences in codes and standards that might be applied. I also mentioned sort of you know, the impact of updated codes and standards. And you have to remember the design and construction period for a building may span, you know, a long time, you know, anywhere from a year to maybe even as long as 2, 3, 4 years. And when you have periods of economic downturn, sometimes projects would be stalled and that period might be longer. So you might have a building that, you know, is finished in 2025, but it was actually designed to codes much older because the permitting process took place much earlier. Or codes were adopted, but at the time those were not yet adopted. So I saw that a lot, that, you know, we were going through the process of adopting NFPA or IBC codes in the MENA region. Well, we were working on projects that were approved, you know, before and starting construction that we were reviewing that were not subject to those requirements. Those are some of the interesting, you know, things that I saw overseas.
Thank you. Thank you.
Within the UK, we have a lot of pressures for development, housing sites, and everything else. And we do not learn. We continue to build houses on floodplains. And then, of course, we have a flood and we have a problem. But also in the UK at the moment, we've got a lot of problems relating to cladding issues, and a lot of buildings considered unsafe. So when we talk about resilience, it's the natural environment, but we're also having issues of the actual constructed buildings. So it was interesting to look at some of the case studies you were referring to.
Thanks for sharing that, David.
Are there any questions, comments by anybody?
Yeah, I have a quick small question. This is David Nicholson with George Fisher.
Please.
Excellent presentation, Shamim. You covered a lot of territory, a lot of information. At one point you mentioned NFPA and the Fire Protection Research Foundation, and you talked about just regular structure fires and arson, and obviously not designed for wildfires, but in any of the resilience-based standards and codes, are fire sprinklers considered part of resiliency, or are they not because it's not designed for large-scale wildfires and such?
That's a great question. You know, and in terms of wildfire, it's different than a structure fire because the hazard is typically not coming from inside the structure, the hazard is coming from outside. And so sprinklers are, I think today sprinklers are considered part of, you know, base building code requirements. But in the wildfire situation, there could be a house that's sprinklered, but still could be ignited from the outside. So some of the discussions that are taking place, I mentioned in the ICC 605 is under development. Also, the IWIC is on a 3-year development cycle. There's actually, you know, been some proposals looking at using sprinklers to wet the building from the exterior as well, to kind of you know, wet down the surface and reduce the impact of embers or brands being launched from the next door building or the next door house onto the building. So I think your question was, are sprinklers considered resilient? I would consider them to be, you know, minimum code compliance. And in a wildfire situation, you have to think even a little bit beyond, you know, the sprinklers on the interior. I hope that answered your question.
Yeah, thanks for that. Just one step further though, because you said you consider them basic requirements, but they're not. I'm thinking more on the residential side when you talked about like apartment buildings and stuff. And I think as far as I know, they're only required in Maryland and California at this point. And so, you know, designing in any different state, would that make my building more resilient to not wildfires necessarily, but to other types of structure fires and arson, like you mentioned earlier?
Absolutely. And that's a great point. Except for the states that you mentioned, most of the states amend out the provisions for automatic sprinkler protection in 1 and 2 family dwellings and in some other smaller apartment buildings. So absolutely, there's another presentation that I do that's called the balanced approach to life safety. And we absolutely advocate for sprinklers plus robust construction as the approach to fire safety. So if you're thinking about a structure fire in a 1 or 2 family dwelling and you have sprinkler protection, or even in a multifamily building, a sprinkler building is probably going to stay up. It's not going to, the way sprinklers work is they limit fire to the compartment that they started in. They control that fire, so it is less likely to engulf the whole structure. In an apartment building, it's also going to ensure that the fire is contained to one unit, and it's going to probably reduce smoke moving towards other compartments as well. So it's a life safety issue, but it's also probably a property issue as well.
Excellent. Thank you very much.
Sure.
Are there any questions or comments? Okay.
I
Okay.
do just want to share, if you enjoyed this presentation, there are a number of other ones that we offer as well. If anyone is interested, I mentioned the balanced approach to fire safety. There's also one that looks a little bit at facade issues. That's the 280, it says 385, it's supposed to say 285 presentation. But you can find more information if you follow this link, or you can scan the QR code.
Shamim, that means, we are looking forward to welcome you back on another presentation as well.
I would love to, anytime.
Excellent, excellent. So with that, I just wanted to say thank you so much again for this outstanding presentation. Thank you for your time, and for everybody, it's been a pleasure. Thank you for watching and attending this great webinar. And please just keep your eyes open on our website.